Hi everyone. In this video I'd just like to practice using some of the properties of integrals that we're talking about in this section. So I'm going to give you different pieces of information and I'm going to ask you if you can draw conclusions based on that about some other question. So first one, the given information is that if I integrate f of x minus g of x from 0 to 2, I get 10. I'm also given that the integral of just f of x from 0 to 2 is 3, and I'm supposed to find the integral from 0 to 2 of g of x. I think my big heads up here would be please use the properties when you're doing these and show me how you're using it. So what I would say is I know based on my properties that I can split this integral up. Trust me, I know that it's really nice to try and be lazy and not have to write this all out, but a really big deal for us to be showing our process. That's actually the biggest deal. So in math, it's not just can I crunch through and get the answer, it's can I clearly show my logical thought process that brought me to that answer. I know that the integral of f is 3, so really I've got 3 minus the integral from 0 to 2 of g of x dx, that does not need a parenthesis, equals 10, which means that we can rearrange however you want. I'll leave the negative integral here. We can subtract 3 off of both sides and get 7, which is going to tell us that the integral from 0 to 2 of g of x dx is negative 7. So answer here, negative 7. Okay, again, I think a lot of people can just look at that one and shout out that the answer is negative 7, but please really think about how you can write out a couple of steps that use your properties and show me this. Okay, let me switch colors since I have these kind of cramped. Okay, so I have the same piece of information as before. I know that the integral from 0 to 2 of my function is 3. And I'm asked if I can then state what the integral from 0 to 4 of my function is. And the answer here, let me just say, because I didn't say it, try and remember to bug you every time. Pause and try and figure these out before I give you the answers. Okay, so suspense over. The answer is that you can't do this. It's not possible. This is a really silly question. If you just start drawing some graphs and thinking about it, maybe your function goes like this. Let's say this is 2 and this is 4, and knowing that this area is 3 doesn't have anything to do with knowing what this area is, or even whether it's positive or negative. So we cannot draw any conclusions about what's happening between 2 and 4 based on knowing the area between 0 and 2. So impossible. Please think carefully about what your properties do and don't allow. Okay, next one. If we know that the integral from 0 to 2 of fx is 3, and we know that function h is just 10 times function f, can we find the integral from 0 to 2 of h of x? So I think we do have properties that can help us out here. This is what we're asked for. We know that h of x is exactly the same as 10 times f of x. One of our properties tells us that if you're multiplying the function by 10, that's the same as multiplying the area under the function by 10, so it's basically just an order thing. It's completely acceptable to find the area under f and then multiply it by 10, as opposed to stretching f by a factor of 10 and then finding the area. And now it's fair for me to say, okay, but I was given the value of that integral, which means the area under h is 30. And again, the visual is good, so I'm not saying you can't use that at all, but please try and show me some steps on this. The visual would be if I take a function, stretch it vertically by a factor of 10, it's 10 times as tall, which means the area is 10 times as big. And that would lead us straight to 30. So I'm not claiming that these are super hard to spot the answers on, but I do want you to try and show me a little of that. And that pre-calc review, transformations can be really helpful on some of these. Okay, I'm going to finally decide to change it up apparently. now I'm going to say, so apparently a different function, the integral from 0 to 2 of f of x is 10, and I have function k that's equal to f of 1/2 x, and I want to decide if I can figure out what the area under k is from 0 to 2. So let's see, if I am looking for integral from 0 to 2 of k of x, we can start off kind of like we did in the last one. That's the same as asking about the integral from 0 to 2 of f of 1/2 x. So thinking about transformations, this is horizontal stretch. So we're doubling all of our x values. Remember, with those x's, you're trying to undo whatever you see so that your y value stays the same. So while that looks like I'm multiplying by 1/2, if we look at an individual point, we want to keep the y the same, we have to double our x value. So horizontal stretch by 1/2. So if I'm thinking of function f going like this, from 0 to 2, and catching an area of 10, if I stretch this horizontally by a factor of 2, so now it takes me twice as long to get to that y value, I don't really have much shot at being able to figure out what this area is. Interestingly, if I was asked for the integral of k to x from 0 to 4, it kind of lines up, I have a little bit more of a shot at that. I still don't think it's trivial. But at that point, we hit all the exact same y values we were hitting before. We've just doubled the widths of our rectangles, so that actually is a fair question. If we keep the heights of our rectangles the same, we double their widths, I think we're going to catch twice as much area. In fact, I don't think, I know that's what's going to happen. But if we double the widths of our rectangle and then we don't double the width of the interval we're integrating over, we're left with something we don't know about because we don't know all of these y values in between. So we have a little bit of trouble. The y values here actually associate, the y values for this orange one associate with the y values between 0 and 1/2 on the original function. So that's a no-go. Okay. Easy one. Integral from 2 to 2 of f of x. You don't really need to write anything for me. I just want you to immediately see those and be shouting out in your head that that's 0. There is no area under a single point. Next one, integral from 0 to 2 of m of x is 6. And we want to figure out if we can actually say what the integral from -2 to 0 of m of x plus 2 is. So again, this is actually getting into more of a transformations question. So yes, this section is properties, and please do practice properties, but I'm also throwing a little bit of this transformations reviewing because it kind of helps us think about substitution when we get there. So whatever this function looks like, let's say it's going like this, and we know here's 0 to 2, so this is m of x. And we know that this area is 6. M of x plus 2, trying to switch colors, there we go, means we need to shift left 2. So we're going to pick up this graph, and this little chunk is going to move over to here, and this peak is going to move over, here, let's see, over 2. Right about there, the peak is more around there. So this graph picks up and moves over. Okay, let's just say it goes something like that. And so that definitely changes the area between 0 and 2. So this is my new one, y equals m of x plus 2. It does not have the same area as m between 0 and 2. But that's not actually what I'm asked for. I'm asked for the area between -2 and 0. And if you think about this, I just took everything between 0 and 2 and slid it over, so it's between -2 and 0. So it should be exactly the same area. So this is actually a fair question. If you shift the function to the left 2 and you shift the limits to the left 2, you've actually caught the exact same area the original function would have caught. Okay, couple more to look at. If I know that the integral from 2 to 4 of m of x is 8, and the integral from 5 to 4 of m of x is 1, can I say what the integral from 5 to 2, I'm sorry, saying it backwards, 2 to 5 of m of x is? So this looks like that addition, subtraction, or not the addition, subtraction, I don't know what to call it, the very first property that we had in the last video. Maybe a little bit of a combination. I can say that the integral from 2 to 5 is the same as the integral from 2 to 4 of m of x plus the integral from 4 to 5. So this is just saying if we have, what are we doing, 2 to 5? So let's say this is 2 and this is 5. If we want to catch this total area, we can go straight from 2 to 5, or we can go from 2 to 4 and then from 4 to 5 and add that up. Same difference. I like this a little bit because I know that the integral from 2 to 4 is 8. The 4 to 5 is not quite right. What I know here is the integral from 5 to 4. But remember, the third property that we were given says that if you want to integrate the other direction, you just have to change the sign. So if we had plus the integral from 4 to 5, we can change it to minus the integral from 5 to 4. And this is something we were given. This is a 1, so it looks like we're getting 8 minus 1, which means the area is 7. 7, okay. Last one, and last one isn't especially hard, but there's one thing that a lot of people will try and do here that is not valid and it'll mess them up. So if I know that the integral from 5 to 8 of 3 times f of x plus 4 is 18, I want to know what the integral of just f of x from 5 to 8 is. So what you want to do here, and again, this is why it's really important to actually use properties and show this, is because if you're doing that here, you, I think, will catch the one tricky thing. Okay, so first thing, I have a property that says I can split up sums inside integrals into 2 separate integrals. Some people want to first move this 3 out in front. You can do that, but you need to be aware that if it goes out in front, it will apply to this 4 as well, so you'd have to change that to a 4/3. So personal preference, I like to leave the 3 there temporarily, first split off the 4, then I can move the 3 out in front. Okay, so that's the first part starting to be dealt with nicely. This is the part that actually the most people mess up. People just want to separate the 4 out completely and not put an integral on it. But you do have to integrate that 4, and we do know the antiderivative of 4 is 4x. So we're actually going to have to take that 4x and evaluate at 5 and 8. And I'll actually give you a graphical way to do that as well in a second. So we get 3 times the integral from 5 to 8. Okay, so 4 times 8, oh my goodness, can I add today? 8, 16, 32 minus 4 times 5, which is 20. So we're getting 12. Okay, so on the graphical way to do this, if you don't really like crunching through the algebra, we're integrating the constant function y equals 4. And this is asking us to find the area trapped under that curve from 5 to 8. So we get a rectangle that is 3 units wide and 4 units high, which means the area is going to equal 12. So more than one way to do this. I don't care which way you choose. Okay. As far as answering my question goes, this now becomes an equation I can solve. So I can subtract 12 from both sides. And I'm going to get 6. And then I can divide both sides by 3. And that's my answer to the question. Okay, so use your properties carefully, think about pictures, show me step by step. You should be in pretty good shape. Thanks for watching.